This is video 3, and I am at the top of page 519, and we are looking at the paragraph at the top. Consider the proportion A over X equals X over B. Now we could say that as A is to X as X is to B. Consider that proportion. In this case, the means of the proportion are the same number, and that number is the geometric mean of the extremes. Do you remember we studied this in the last lesson? That these two numbers, or in this case variables, are the means, and the first and last are the extremes, which makes sense. So the means of the proportion are the same number here. We have an X here and an X here. That number is the geometric mean of the extremes A and B. The geometric mean of two positive numbers is the positive square root of their product. Now, bear with me. I know this sounds a little bit like Greek, but I'm going to read that again, and we'll be understanding it better as we look at the mathematics of it. So reading it again, the geometric mean, which in this case is the two x's, of two positive numbers, which in this case is the A and the B, is the positive square root of the product of those numbers A and B. So the geometric mean of A and B is the positive number x such that x equals the square root of AB, or, meaning the exact same thing, x squared equals AB. Now notice that these are the exact same thing. X equals the square root of AB, or x squared equals AB. Let's look at how we get from here to here. If we wanted to do that, we would take the square root of this and the square root of this, and we would be left with an x on the left and a simple square root of AB on the right. So now you see how those two are related algebraically. So we're going to be solving for geometric means. Sorry, my hand's going to be in the way very briefly, and I need to resituate a little bit. We're going to be solving for geometric means, and we're going to use example 2 to look at how to do that. Find the geometric mean of each pair of given numbers. If necessary, give the answer in simplest radical form. So we're going to find the geometric mean of 4 and 9. Now going back to what we were looking at before, that would be as if this was written 4 over x is equal to x over 9. That might resonate with you because that's the form that we just looked at in the paragraph above. So we want to find the geometric mean. We want to find what these x's are. The way we're going to do that is we're going to use either one of these equations. I generally start with this one, but we often will move to this one. So let's start here, and let's say our x squared is equal to, hold on. Let me undo what I did when I was walking through this with you. There we go, that's going to make it easier. Okay, our x squared, as you can see right there, is equal to the a times the b, or in this case, the 4 times the 9. So we say x squared is equal to 4 times 9, or 36. At that point, we're left with x squared equals 36, and of course, x equals 6. All we did there was take the square root of the x squared and the square root of the 36, just as I showed you up here. And when we took the square root of both sides, we were left with x equals 6. Let's look at another one. Let's find the geometric means of 6 and 15. Now remember what that looks like. That would be like saying 6 over x is equal to x over 15. We are going to say x squared equals 6 times 15, or x squared equals 90. In this case, we don't have a simple square root, so we are going to take the square root of both sides, the square root of x squared and the square root of 90, and the square root of x squared equals x, and then we're left with the square root of 90, which simplifies down to 3 radical 10. That's because the 90 was made up of a 9 times a 10, so we have the square root of 9 times 10, and we take, that looks a little bit like a 4, but it's a 9. We take the square root of that 9, and that's 3, and there's nothing we can do with the 10, so our final answer is 3 square root of 10. Let's go through 3 more of these quickly, and this time I won't write them in fraction form, but as you can see, we cross-multiplied here, solving a proportion just like we did in our last chapter. But we're going to kind of skip that thought process now, just applying the geometric means without having to walk through that step. So let's look down here. Find the geometric means of each pair of numbers. If necessary, give the answer in simplest radical form. This is check it out. Number 2, 2a, 2b, and 2c. So in this case, we're finding the geometric means of 2 and 8. So I could say x squared equals 2 times 8. Now I jumped ahead and just used, let me move my phone back up so you can see it. I used this equation this time. I said x equals the square root of those two numbers multiplied together. So I just said x equals the square root of 16, or x equals 4, which is the square root of 16. That's the same as if I had started with the reverse, excuse me, equation where I had x squared equals 2 times 18. Basically, that would be the step before taking the square root of both sides, which leads us to here. All right, let's look at 2b. Here we could say x squared equals 10 times 30. Now again, I kind of did that step in my head, took the square root of both sides, and the square root of x squared is x. The square root of 10 times 30 is the square root of 300. And when we reduce that radical, it reduces to 10 radical 3, because 300 is made up of a 3 times a 100. The only thing we can take the square root of there is the 100. The square root of that is 10, so that has come out of the radical, and we're left with the 3 in the radical, which cannot be simplified. So here our geometric mean is 10 radical 3. And the last one, 8 and 9, I'm going to skip the first step right here and just say x equals the square root of 72, or x equals the square root of 8 times 9. That's what I've done here. And then I simplify that radical, and x equals 6 square root of 2. All right, I hope that helps. I am going to stop this video, and we will then move on to video 4.